Hello and welcome to another Fathom SmartTALK webinar, where we bring in thought leadership to discuss the real impact of transforming maritime and shipping. My name is Craig Eason and it's a pleasure to welcome you here to discuss technology evolution and how connectivity and data are impacting performance, operation and in turn ship design. Last year was the year where the connectivity question reached a tipping point. Satellite service providers tell us that ever more vessels are getting connected. Performance software providers are riding high on increased demand, and tests on various types of autonomous or remote operations hit the headlines. One of the projects that highlighted these developments was performed by Wärtsilä and the offshore vessel owner Gulfmark. In 2017, they demonstrated that a vessel in the waters off the UK coast could be controlled remotely by operators in the US. We will hear from Stephen Lee in the latter part of this webinar about the reasons Gulfmark took part in the trials and why it's keen in being involved in seeing whether these levels of autonomy will create anything new. But first we'll hear from Wärtsilä, the Finnish engineering company that is one of a handful of companies really pushing out the autonomous boat, and UK-based BMT Smart, which is ahead of the game when it comes to performance solutions. First, Riku-Pekka Hägg, VP Ship Design, on the link between what we are doing today and how ships will look in the future.
The marine industry is in transformation. The market is being reshaped by new ways of collaboration and smart technology. The smart technology can bring many opportunities, but one needs to have an holistic, systematic approach that is not only dependent on technology, but also effective collaboration and a comprehensive global regulatory framework. The new standard set by digitalization requires the operator to look at the vessel or the fleet as a whole. Looking at the big picture allows us to optimize each of its parts. Already today there are 4 forces that have started to reshape the maritime sector. The introduction of platforms and marketplaces for vessels and port capacity sharing will lead to higher utilization of cargo fill rates. This has been enabled by new digital technologies coming into the maritime sector: blockchain, cloud computing, artificial intelligence. Those will lead to lower shipping prices, real-time match to potential customers, reduction of number of intermediators, as well as improved enterprise-to-enterprise cargo tracking. Combining system and product engineering know-how, data depths, and advanced computing allows us to transform raw data into value-creating insights. Once again, using the digital technologies, artificial intelligence, simulations, cloud computing, that will lead to de-risking of the decision-making, optimize performance, allow us to do predictive maintenance, detect anomalies, as well as optimize the fleet. A continuous development of modular solutions will make ships smarter, adding advanced navigation capabilities, increased levels of automation, connected systems, and insight-driven value-added services will help us to do advanced route planning, collision prevention, auto-docking, remote and automated operations, as well as having holistic energy and emission management, and to coordinate the fleet. Ports will focus on autonomous operations and automated information exchange between vessels, both authorities and logistic partners. Using new technologies, advanced robotics, additive manufacturing, you are able to reduce the waiting times, optimize sailing times and berth pricing, increase reliability and speed of vessel-to-port communication, and automate piloting, dock and berthing operations. Disruption, and especially when we talk about digital disruption, has the potential to overturn incumbent companies and reshape markets faster than perhaps any force in the history. And by digital we mean the convergence of multiple technology innovations enabled by connectivity. And this disruption and the change is not linear, it's exponential. Let's take an example of an Uber, how the user experience is disrupting taxi businesses around the world. This could well happen also in the maritime industry. You have clean cars, safe environment, enabled by an application which works everywhere, and you don't need to carry cash with you. And an Uber managed to combine different value propositions cost value, experience value, and platform value in the same business model, which disrupts the existing businesses. What does these different technologies and potential new business models has to do then with the engineering and ship design and shipping operations? When we design ships, quite often everything is based on experience, know-how, and an education. Artificial intelligence uses the computing power and the data available from different sources. It can be performance data, it can be tank testing data, it can be pictures, it can be motions, it can be weather data. Combines all that and uses computing power and algorithms to come up with the new solutions, which is based on the experience, what comes out of the data. But moreover, the systems are also able to learn by themselves and educate themselves to become better and better. And that will change the way how we think, because the way how human, for example, engineers and designs a vessel is based on how we are used to do things. And with computer, typically you don't have those limitations. So what does that has to do with the ship design and the vessel operations? The ships are getting smarter with the new technologies. Ultimately, they will be capable of autonomous operations, which means the systems will do some of the operations what traditionally humans have been doing. That means that ultimately you could have reduced crew or even no crew in the future. But also the way how the vessel performs the operations will be different. It will be using sensors and the data and the artificial intelligence there. And then ship designers have to learn those technologies and understand the implications for the vessel. So all in all, the future looks like the connectivity will be the key. And understanding the connectivity and its implications for value chains, logistic chains, will lead to a different type of vessels, more advanced vessels, more safe operations, more reliability, and more efficiency in the logistic chain.
That's Riku-Pekka Hägg from Wärtsilä on the impact of disruption on ship design operations and logistics. We're looking at the importance of knowing what's going on in the industry, gaining an insight into what may be happening literally tomorrow. And that's what BMT Smart has been doing for some time now. And when one looks at the societal transformations, it's not a huge leap of imagination to see what could happen in the areas that we work in shipping. Matthew Streeter from BMT Smart, based in South England, says artificial intelligence will be an accepted tool in shipping in a decade. The inspiration for AI comes from biology and what is called artificial neural networks.
Over the last few years, we've heard a huge amount about digitalization and big data in the shipping industry. And I think one of the key things to remember with big data is it's not about the volume and the quantity of data that we're recording it, it's how we actually use that information. A lot of people have started measuring data from their ships, but they don't use it, or they use it too late, and they're not really taking the benefit from that data and translating into real world gains. What we're seeing is predictions that in the next 10 years, all of the shipping industry will use artificial intelligence and automation, whether it's to optimize voyage parameters or with autonomous shipping. What we need to see is artificial intelligence feeding into weather routing and voyage optimizations to make sure we use that data to improve the efficiency of the way we run the shipping industry. So what can we learn from the likes of Uber, Google, Facebook, Apple? All of these companies have been working on artificial intelligence for the last decade, and we use it every single day. Uber uses it to predict when there's going to be surges in people wanting to use their service, which means that they can get more drivers available, which means they can provide a better service to the end user. They also use it to look at routing and making sure that they deliver people in the most time-efficient fashion. They also use it to predict costs of a journey, because of course it's all on a fixed price basis. Siri, Google Now, Cortana, well, we all have personal assistants now on our laptops, and they all rely on artificial intelligence to help make decisions to support us. Facebook uses AI to recognise faces when we upload photos to save time. It's all about using the information they have and self-learning algorithms to save time and improve the end-user experience. But how do we use that in the shipping industry? How do we turn this, a heat map of the 50 ships over the last 6 months, into tangible benefits and operational gains? At BMT Smart we use artificial neural networks. They're biologically inspired simulations performed on computers to perform certain specific tasks like clustering, classification, pattern recognition. In general, it's a biologically inspired network of artificial neurons configured to perform specific tasks. We use them all the time. Uber, Siri, search engines, they all use these self-learning models that can train and then relearn all of the time to create connections and patterns in data that a human just wouldn't be able to do. But how has this been used in the past by other companies to actually make big gains? Well, UPS started the Orion program in 2003. What they were really looking to do was optimize the way they were moving and transporting deliveries in the US. They started developing their algorithms in 2003. Through to 2008, they continued that development process until they got to the point where they needed to gather data. So they installed telematic devices on every single delivery van they have. By 2010, they were testing prototypes and deployed them on 8 sites. 2013, 10,000 routes on their first major deployment. And 2016, they were using it everywhere. But what did it do? Every night, Orion is running and it's looking at where deliveries need to be taken from and delivered to. They run thousands and thousands of simulations to optimize the best route for delivering the packages in the most efficient way. This has resulted in a saving of 100 million miles a year not having to be driven. That's 45 million litres of fuel saved. Not only has incredible environmental benefits, but it also saves UPS a huge amount of money. We need to start making these changes in the shipping industry. We need to use artificial intelligence to provide information to operators and shipping companies so they can make better informed decisions. At BMT, we use artificial neural networks to model ship performance. It means at the beginning of a voyage, we can start predicting fuel consumption and how a vessel's actually going to operate across that voyage with forecasting meta-ocean data and models that are based on in-service data. These models can update in real time, which means as soon as information comes in, the models are updating, and it means the predictions are getting more accurate every single day of a voyage. Instead of getting to 7 days into a voyage and looking back at the performance of the vessel, where it's going to be, how much fuel it's consumed, these decisions can be taken on the first day of a voyage. Artificial neural networks really help to identify relationships that a human isn't able to do, or at least is not able to do it in a timely manner. And we really need to push this technology out so that we can start improving the efficiency of the way that ships are operated.
That's Matthew Streeter from BMT ending the first part of the webinar. Next up, I'll be talking to Stephen Lee, General Manager of Operations at Gulfmark. He's based in Scotland, and it was one of his vessels, the Highland Chieftain, that was used in that remote control experiment last year.